Okay, guys, so far in Unit 3, we've gone over the rules of exponents. We've been introduced to exponents. We went over the rules for exponents. We practiced the rules for when you have the same base raised to an exponent and you're multiplying the exponents, you can add the exponent when you're multiplying the bases, you can add the exponent. When you're subtracting the bases, you can divide the exponents. Things like that. And then in 5.4, we got introduced to polynomials. Poly means many. So a polynomial is a function that's made up of many terms. A term is separated by a plus sign or a minus sign. The term is negative if the sign in front of the term is a minus sign. So that's kind of like plus a negative term, okay? We then combined like terms by adding and subtracting polynomials. So when you think adding and subtracting polynomials, remember you're just combining like terms, but you need to watch out to make sure that you don't that you distribute the minus sign if you're subtracting a polynomial from another polynomial. If you're subtracting the whole polynomial, all three terms, you're going to need to distribute the minus sign. It's reversed for me, I think so. You need to distribute the minus sign to all of the terms, to each individual term inside the parentheses of what you're subtracting from that other polynomial, okay? We use combining like terms for adding and subtracting, but today we're multiplying polynomials, so we're going to use the rules for exponents, okay? That's the main difference, but polynomials just mean something long, like what you think of when you think of algebra, right? Okay, I'm going to pause this. I'm going to turn on my camera to the page, turn on the light, and we'll start. Okay, so to review this, to review before we start multiplying polynomials, multiplying by monomial, 1, okay? We're going to state the distributive property. The distributive property is multiplication. All right, like 2 times 2 is 4, right? Because we just multiplied 2 times 2. And then the distributive property would be more like 2 times 2 and 5 becomes 2 times 2 plus 2 times 5, which is 2 times 2 is 4, 2 times 5 is 10. Good. Also, so we took the 2 to multiply by 2, took the 2 multiplied by a positive 5. 2 times 2 is here. 2 times 5 is here. And we can see that you get the same answer as if you were to solve it a different way. So we got 2 times 2 plus 5, 2 times the quantity 2 plus 5 is equal to 14. And 5 plus 2 is 7. So 2 times 2 plus 5 is also 2 times 7, which is also 14. So you end up with the same answer from the distributive property as from just simplifying and multiplying. The reason we're learning the distributive property is because there are situations where we can't combine because it's not a 2 and a 5. It's two terms that are not alike enough for us to combine them, okay? So the way to write the distributive property is A times the quantity B plus C is equal to A times B plus A times C, okay? I would like the parentheses just because in case one of those is negative, it helps. But you can also write it just as A times B plus C is equal to AB plus AC. If you are proficient in parentheses. Good? Okay. So we're going to use the distributive property to multiply monomials. And then we will go on to multiplying polynomials. Multiplying polynomials is just going to be more like A plus, oh, sorry, you can't even see that. A plus B multiplied by C plus D. That would be a polynomial multiplied by a polynomial. This would just be a monomial times a monomial. Good. Okay, let's see if I can do this. Let's see if we can do this. Here we have 9x squared. The parentheses means multiplied by negative 8x cubed. So we're just multiplying a monomial times a monomial. It's kind of like just similar to multiplying 2 times 2. Okay. What you want to multiply is the parts of each monomial that are alike. Now the like terms doesn't have to be the same exponent. It's just the same base. 9 and negative 8 are both numbers, and then x is the same variable. So 9 is going to be multiplied by negative 8, and then x squared is going to be multiplied by x to the third. Okay, so if I were to split that up, it would be 9 times negative 8 times, because it's all being multiplied, right? 9 times x squared times negative 8 times x cubed, because the coefficient in front of the variable just means x squared 9 times, right? So if I think of x squared 9 times, sorry, to just get a little bit to over-explain a bit. 9x squared is 9 of these. Nine. Good. That's 9x squared. Or there are 9 of them. I'm taking x squared and combining 9 of them. X squared times 9 is 9x squared. How many are there? There are 9. Okay. So you can think of 9x squared times negative 8x to the third as 9 times x squared times negative 8 times x cubed. So that's an easier way to think about it so that you can pick out what goes together. The 9 gets multiplied by the negative 8. The x squared gets multiplied by the x cubed. Good. So if you're wondering why I can multiply the 9 and the negative 8, it's because 9x squared is the same as 9x squared is the same as x squared times 9. They're right next to each other. They're being multiplied. So each of the terms from our previous, from 5.4, each of the terms is the variable being multiplied by the coefficient. X is being multiplied by 12. X squared is being multiplied by 9. X is being multiplied by 9. X is being multiplied by 2. X squared is being multiplied by 8. X is being multiplied by y and negative 4. Y is being multiplied by x and negative 4. Negative 4 is being multiplied by x and by y. Y squared is being multiplied by 6. Okay, so 9 times negative 8 is, I think, negative 72, right? Times, and then remember the rules of exponents are, what was it? X to the power of a times x to the power of b equals x to the power of a plus b, right? So x squared times x cubed is x to the power of 2 and 3. So our final answer, the most simplified form, right? We're multiplying it, but we're just simplifying it because we're still going to have the variables. We're just giving it a different, instead of 2 monomials, it's going to be 1 monomial. Negative 72, x, 2 and 3 is 5 to the 5th, right? 9 times -8 is -72. X squared times x cubed is x to the 5th. Should we write down the rules of exponents? So the rules of exponents real quick are, the 0 rule is anything to the power of 0 is 1. Sorry. The identity is anything to the power of 1 is itself. Okay. The product law, that's what's going to come up a lot today, is a to the power of m times a to the power of n equals a to the power of m plus n. Okay. The quotient rule, a to the power of m divided by a to the power of n equals a to the power of m minus n. So these are from 5.1 and 5.2. And then, not sure we need to do a negative exponent law today. So we'll just skip to the power of a power. Yeah, power of a power is a to the power of m raised to the power of n is equal to a to the power of m times n. So if you're multiplying the bases, you add the exponents. If you're dividing the bases, you subtract the exponents. If you're taking that exponent to the power of another exponent, you multiply the exponents. Okay? Power of a product would be a times b to the power of m equals a to the power of m times b to the power of m. And then the product rule would, or sorry, the quotient rule, power of a quotient rule, a divided by b to the power of m is equal to a to the power of m divided by b to the power of m. Good. So those are the rules we are using today. We just used the product of exponents rule. We got 9x squared times -8x cubed is -72x to the 5th. Now we're going to say 1/5 x squared times 1/3 x to the 6th is 1/5 times x squared times 1/3 times x to the 6th. Good. What are our like terms? We have the like terms 1/5 times 1/3. And then we have times x squared times x to the 6th. When you are multiplying fractions, remember you just multiply straight across. So 1/5 times 1/3 is just 1 times 1 is 1. 5 times 3 is 15. So 1/3 times 1/15, 1/3 times 1/5 is 1/15. And then we have x squared times x to the 6th. The exponent rule is that if the bases are being multiplied and the bases are the same, you add the exponents. So that just becomes 1/15 x to the 8th. Good. All right. Number 4 is 2.9 x to the 4th times 4x to the 7th. Remember, just like up here with the fractions, what we're practicing today doesn't change just because we're practicing it on a fraction, or you might be practicing it on a decimal. It doesn't change what we are practicing. 2.9 times 4 times x to the 4th times x to the 7th. Good. 2.9 times 4? Don't know. 11.6. 11.6 times x. The bases are the same, and we're multiplying the bases, so we just add the exponents. 11.6 times x to the power of 11? 7, 8, 9, 10, 11. Good. All right, here are, so those were each 2 monomials. Here we have 3 monomials, okay? So we're going to multiply the 3 times the -4 times the 3. Okay? You don't need parentheses if you have the multiplication sign. Positive times a negative times a positive is going to be a negative. Times x to the 8th times x. You already, the 4 is the negative. The x is not negative. Times x to the 5th. Okay? You can make, yeah. If you wanted to write it out like this x would not be negative because the negative is with the 4. But the whole term is negative. Negative 4x is negative 4 times positive x. And again, you don't have to write it out like this. You can just do it in your head. 3 times negative 4 times 3. Negative 36. And then we have x. We have 8 and, remember this is 1. Don't forget that one. And 5. Negative 36. X to the 8 plus 1 is 9. Plus 5 is 14. Doing a lot of counting on my fingers today. So we have negative 36x to the 14th. Does that make sense? Well, we have a positive, a negative, and a positive, so it should be a negative. And then we have x to the 8th, x to the power of 1, and x to the power of 5. 8 and 1 and 5 is 14. So yeah, it's looking like it's making sense. That fits, okay? Here's another one, looks very similar. 5 times negative 5 times 5 times x to the 8th times x to the 1st. I'm just going to say so that I can add it faster and don't forget it. 5 times negative 5 is negative 25. Negative 25 times 5 is negative 125. X to the power of 8 and 1 and 6, because when you are multiplying the bases, they're all the same. You just add the exponents. Negative 125 x to the 15th. So like almost the same problem. Good. Okay. We're still multiplying by a monomial. But now, so this was monomial times monomial times monomial. These were just monomial times monomial. Now we have a monomial times a binomial. Okay. You're going to use the distributive property very carefully, okay? That 12x is going to get multiplied times 9x and times negative 3, okay? So 12x times 9x, those are both positives. 12 times 9 is 108. Well, I mean, no, I might be rushing. 12 times 9. Very important, there's also x times x. That x and that x, okay? 12 times 9 times x, just like we were doing over here, right? 9 times 8 times x squared times x to the 3rd. 12 times x times 9 times x, okay? And then we're going to go on to 12x times negative 3. So that is minus, right? 3 times 12 times x. Okay. So this was a minus sign between them. So you need a sign to remain between the two terms. So you're multiplying a monomial times a binomial. Monomial times a binomial is going to give me a binomial. Okay. I cannot forget that there was a sign of subtraction between them, so there should remain a sign of either subtraction or addition between them. Monomial times binomial is going to give me a binomial. So we said 12 times 9 is 108. 108. And then x times x is x squared. Negative 3 times a positive 12. Negative 36 times x. Okay. Monomial times a binomial is going to leave me with a binomial. Here we have a monomial times a trinomial. Leave me with a trinomial. I should have 3 numbers at the end. I should have 2 signs, either 2 addition signs, 2 subtraction signs, or an addition sign and a subtraction sign, okay? So very carefully, 2x times 8x squared you can just say plus 2x times negative 4xy. You are also welcome to say minus and make that 4xy a positive. Depends on whether you would prefer to have a minus sign here and multiply two positives, or keep the plus sign here and multiply a negative and a positive, okay? Those would be the same. Plus 2x times 6y squared. Good? Okay. I'm going to run out of space, so switch over to here. 2x times 8x squared is 2 times 8 times x squared, right? Plus, and then this one was 2 times negative 4 times x times y. Got it? 2 times negative 4 times x times y. I gave them each a 1 because they're each to the power of 1, and we're going to be using the rule of exponents. So it's helpful to not forget that that's a 1 and not a 0. Okay? Plus 2x times 6y squared would be 2 times 6 times x times y. So 2x times 8x squared is this one. Two times negative 4 times x times y is distributing that one. And then 2 times 6 times x times y squared is distributing the 2x to the 6y squared. Okay, now we just simplify. That was the hardest part, I think. The part you're most likely to make a mistake, I would say, but it depends. Now we're just going to simplify. 2 times 8 is 16. This is the same base, so I'm just going to use the rule for multiplying exponents, which is you keep the base and you add the exponents because the bases are being multiplied. 2 times negative 4 is a negative 8. X and x are the same base, but y is not the same. So I just leave it right there. 2 times 6 is 12. X, y squared, because there was nothing to combine. Those are not the same bases. Good. Simplifies to 16, x to the third, minus 8x squared, plus 12xy squared. Okay. Now, if you want, we see that. Did I do something wrong? Yeah, I forgot him. Good. Now, we have 16x cubed minus 8x squared y plus 12xy squared. I said that this was the hardest part, and then I made a mistake down here. Check your degrees. This is a degree 3, this is a degree 3, and this is a degree 3. So if these were in descending order of degrees, 2, 2, 2, they should still be in the correct order of degrees so that you can kind of like eyeball if you made a mistake, if that makes sense. If that doesn't make sense to you, do not worry about it, okay? 9 is negative 8 times y multiplied by the quantity negative 6y squared plus 7y plus 5. Okay, so we're going to do the same thing. Negative 8y times negative 6y squared would be negative 8 times negative 6 times y to the first times y squared, right? Now we're going to go negative 8y times positive 7y. So that's going to be, I'm just going to say plus. Good, because I need a space holder because I need 3 terms. 1, 2, 3. There's my first term. My next term, I'm going to put a plus between them. Negative 8y times positive 7y becomes negative 8 times positive 7 times y times y. And then now I have plus, right? So that was that plus sign, that's that plus sign. Negative 8 times a positive 5. And we can just say that that's negative 40. Those are, oh, I cannot say that. Negative 40y. All right. Negative 8 times negative 6. Negative times a negative is a positive, right? Negative 8 times negative 6 should be 48. Y times y squared is y to the third. Negative 8 times a positive 7. Negative 56. Y. That's y1, y squared, minus 40y. Good. So we multiplied degree 1 times a degree 2, we got a degree 3. We multiplied a degree 1 times a degree 1, we got a degree 2. We got multiplied a degree 1 by a degree 0, and we got a degree 1. That tracks. Number 10 asks for negative 7 times negative 12 times x to the 7th times x to the 4th as our first one, right? Oh, sorry. Then we've got, we'll just say plus, negative 7 times negative 5 times x to the 7th times x squared, because they're negatives. Good. Last one, negative 7. So we're going to say plus. Negative 7 times 8 times x to the 7th. That's it, because 8 was a constant. Good. All right, let's simplify. Negative 7 times negative 12. 84. Times x, 7 plus 4, right? Plus 7, negative 7 times negative 5 is 35. X, 7, and 2. Negative 7 times negative 8. Didn't we just do that? Negative 56. So we're saying plus negative 56. X to the 7th, because there's no x with the 5. Which one are we on? Sorry, we're on 10. There's no x with the 8. Good. Simplify. 84x, 7, 8, 9, 10, 11. 84x to the 11th. And then 35x to the 9th plus a minus 56 is going to be negative 56x to the 7th. Good. Let's compare degrees, okay? So right here we've got degree 7, degree 4, degree 2, and degree 0. So 7 and 4 gives us 11. 7 and 2 gives us 9. 7 and 0 gives us 7. So that tracks. It's less likely that we made a mistake if our degrees track with each other, okay? So 3x to the 5th y squared is going to be multiplied by 5x cubed. plus, okay, 3x to the 5th y squared times negative 2x squared y squared. So you can say it's a negative 2 and you're adding it, or you can say it's minus a positive 2, whichever way, okay? Plus 3x to the 5th y squared times 2y cubed. Got it? So we see what we distributed to all three, okay? Now let's simplify each part. We have 1, 2, 3 terms. We'll end with 3 terms because it's a monomial times a trinomial, so we'll end with a trinomial, okay? 3x to the 5th y cubed times 5x to the 3rd. I'm just going to put it in order. 3 times 5 times x to the 5th times x to the 3rd times y squared. Good. 3 x to the 5th y squared times negative 2 x squared y squared. 3 times negative 2 times x to the 5th times x squared times y squared times y squared. So that's that 3, that's that 5, that's that x, that's that y, that's that x, okay? That's that guy, 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 that's that guy. Just putting them in order so it's easier to combine. Plus 3 times a positive 2 times x to the 5th times y squared times y to the 3rd. 3, 2, x to the 5th, y squared, y to the 3rd. All right, go ahead and simplify this. 3 times 5 is 15. X to the 5th times x to the 3rd is x to the power of 5 times 3. Three times negative 2 is a negative 6 times x to the power of 5 plus 2 times y to the power of 2 times 2. Plus 3 times 2 is positive 6 times x to the power of 5 times y to the power of 1 plus 3. Oh, no, 2 plus 3. My arrow messed me up. I knew it would. At least I remembered. Good. Keep simplifying. 15 times x, 5 and 3 is 8. Y squared. Plus a negative 6 is going to be minus 6. X, 5 plus 2 is 7. Y, 2 plus 2 is 4. X to the power of 5. Y to the power of 2 and 3 is 5. Compare. This was so we're just comparing degrees. This was a degree 7. This was a degree 3. That was a degree 4. And that was a degree 3. So 7 and 3. Oh, sorry. And let's compare. Let's compare these degrees. 8 and 2 is 9, 10. 7 and 4 is 11. 5 and 5 is 10. Eight, 9, 10, 7, 8, 9, 10, 11, 5 and 5 is 10. All right, so we have 7, a power of 7 and a power of 3 becomes a power of 10, 7, 8, 9, 10. 7, power of 7, degree of 7 and degree of 4 becomes a degree of 11. Degree of 7 and degree of 3 becomes a degree of 10. Let's say that works. All right, guys, we are not done yet because we are fitting both 5.5 and 5.6 into this one video. So you are welcome to take a break. Now, that was all multiplying monomials, okay? So we took a monomial and we distributed it through a polynomial. Now we're going to multiply polynomials, every term in the first term by every term in the second term. So if before we had 2 times 3 and 1 equals 2 times 3 plus 2 times 1, right? 2 times 3 is 6. 2 times 1 is 2, 6, 7, 8 equals 8, right? Which is the same as 2 times 4, also 8. Okay, this time we have a binomial here. So we have 2 and 3. We're going to multiply it by 4 and 1. Good. We're taking the 2 and multiplying it by the 4. Not enough room at all. 2 times 4. 2 plus 3 times 4 plus 1. Good. 2 times 4. And then we're also going to do 2 times 1. So we distributed the 2 to the 4 and the 2 to the 1. Now, everything with the 3. Plus 3 times 4. Good. And then three times 1. So we did the 2 times the first term, 2 times the second term, 3 times the first term, 3 times the second term. 2 times 4 is 8. 2 times 1 is 2. 3 times 4 is 12. 3 times 1 is 3. 8 and 2 is 10, plus 12 is 22, 23, 24, 25, 25. Good. And we can show you that it also equals 25 if we do it a different way. 2 plus 3 times 4 plus 1 equals 2 times 3 is 5. And 4 plus 1 is 5. 5 times 5 is also 25. So it's just a different way to do multiplication. You have to do it very carefully because you can't combine. We can combine 2 and 3 just fine, but we can't combine y and 1. Okay, so that's what it means by multiply every term in the first polynomial by every term in the last polynomial. Okay, and then we combine like terms. We couldn't combine in like terms when we were multiplying by a monomial because just like we didn't have any like terms in those parentheses. So we had no like terms between this guy, and this guy. Multiplying him by x to the 5th and y squared isn't going to make him compatible with him. However, it is possible that you will end up with like terms if you use the distributive property on, because you have 2 different numbers multiplied by 2 different numbers. Okay. Let's use the distributive property to multiply polynomials. Multiplying polynomials is distributing with more terms, okay? Y plus 1 times y plus 2. We're going to take y times y. Okay? And then we're going to do y times 2. Good. Now we're moving on. We did the y. Now we're moving on to the 1. Plus 1 times y plus 1 times 2. Y times y times 2, 1 times y, 1 times 2. Now we simplify. Y times y was y squared, because it's 1 plus 1 becomes 2. Y times 2 is just 2y. Y times 1 is just y. And then 1 times 2 is just 2. And you can see that we do in fact have like terms now. Our like terms are 2y and y. So what we end up with is y squared plus, we're just adding, so we're combining like terms, so the y stays the same, 2y and 1y is 3y. Oops, sorry, plus 2. Final answer. Good? All right, same with the b. b times b plus b times -8. Or you can say minus b times +8 if you want, okay? Plus -7. Oh, sorry. So that was b times -8 plus -7 times b plus -7 times -8. Okay? b times b is b squared. b times -8 is -8b. So you could put plus -8b, or you could just say minus 8b. -7 times a +6 is minus 42. And then here we have plus 7 times 8, or -7 times -8, 56. Good? Oh, sorry, it was 42b. Look at, I'm making the mistake that is very frustrating. So then it has b squared, but -8b and -42b are combinable. So -8 minus 42 is -50. And then there's nothing to combine with the +56. Good? Now we are going to explain FOIL, okay? FOIL is fully distributing, and you can apply it to all polynomial multiplication. FOIL is first inside. That's not how you spell FOIL. That was going to look so good, and now it's not. Outside inside. Maybe if I just do this. And first, outside, inside. How many good colors? Last. So your first is going to be the first term of both your first binomial and your second binomial. X times A. Your outside is going to be the outsidemost of the entire thing. X times B. Inside, it's going to be these two inside ones, Y and A. Y times A, because I don't know why I'm putting them in parentheses. I disagree with this. We're multiplying. And then my last ones are going to be the very last ones, Y times B. And that's how you FOIL. First, outside, inside, last, and you add them all together. So it'll be first plus outside plus inside plus last. So my first was X times 5, or 5, or sorry, X times B. X times A. Why did I call the A a 5? And why did I just try to put it in focus and it went out of focus? X times 5, guys, what is going on? X times A. Outside was X plus times B. Use the wrong color. Inside was y times a. And then my last one was y times b. Now I'm like all discombobulated because I made a big mistake. Just the 5 to the a was a big mistake. X times a plus x times b plus y times a plus y times b. So we have our x times both of them, and then we have our y times both of them. X times both of them, y times both of them. So it's just ax plus bx plus ay plus by. And you can change the order. Ax plus ay plus bx plus by. That doesn't change the value. Good? All right, so let's use the distributive property to multiply polynomials. Let's see if I can do a real FOIL. FOIL. First, 3x times x. Outside, 3x times -5. Inside, 10 times x. Last, 10 times -5. Good? So because I kept the negative with the 5, I'm going to add all of these. 3x times x is 3x squared. 3x times -5 is a -15x. 10 times x is just 10x, and then 10 times a -5 is a -50. So it'll be 3x squared minus 15x plus 10x minus 50. And we're just going to do a ton more of these examples. So you can feel free to pause it, go work on the homework, come back if you want to see more examples, fast forward if you need to. 3x squared. -15x and 10x are like terms. So minus 15 plus 10 is a -5x minus 50. And that is as simplified as you can make that trinomial. Good? Y minus 4. Ooh, don't go away yet. I just said we're keeping doing examples. But it's important that we see how to do this. This is not y squared minus 4 squared. Okay? It is not that. It is that whole quantity squared or times itself, right? Because if we have x squared, we're saying that's x times itself. If we have 3x squared, we're saying that's 3x times itself. Oh, sorry, you couldn't see any of that. X squared is x times itself. 3x squared is 3x times itself. So we cannot call it y squared minus 4 squared. We have to call it y minus 4 times quantity y minus 4. And then we FOIL it again. First would be y times y. Outside would be y times -4, which is -4y. Inside would be -4 times y. And last would be -4 times -4, which is positive 16, because a negative times a negative is a positive. So that all becomes y squared minus 4y minus 4y plus 16. Combine like terms, y squared minus 8y plus 16. Good? All right, let's try it again. 3z plus 7 squared is 3z plus 7 times 3z plus 7. First, we have 3z times 3z. 3 times 3 is 9. Z times z is z squared. Outside, 3z times 7. Three times 7 times z. Inside, 7 times 3z. And then last, 7 times 7. which is like 49. And what's 3 times 7? 21. Sorry, I don't think you can see that. So that all becomes 9z squared plus, because these are all positives, okay? Plus 21z plus 21z plus 49. Did I fit it? I fit it. Good. These two are like terms. So we have 9z squared plus 42z's plus 49. And that is as simplified as you can get. Good. All right. You can FOIL it, or you can go ahead and do it this way, whatever way you prefer. X plus y squared times x plus 11y times x plus 7y. I have no idea what I said that first time. X times x would be our first. X times 7y would be our outside. 11y times x would be our inside. And then 11y times 7y would be our last. X times x becomes x squared. X times 7y becomes 7xy. 11y times x is 11xy. And then 11 times 7 is 77. And then y times y is y squared, just like x times x is x squared. Okay? Now we put all of these together. And we get x squared plus 7xy plus 11xy plus 77y squared. These are all two terms, 2 degrees, 2 degrees, 2 degrees, 2 degrees, 2 degrees. So you don't need to change the order. You can if you want, but you don't have to. You do need to combine like terms. X squared, 7xy and 11xy are the same terms. They are like terms because they have x to the first power and y to the first power. 7 and 11 is 18. Good. Or you can say xy plus, or sorry, x squared plus 77y squared plus 18xy. Or you can leave it like that. All right. So notice that these have all been positives. Our binomial times our binomial have been positives. That was a positive, so it was a positive times a positive. Positive times a positive. There was a negative. So if we had a minus sign between them. We had a minus sign down here. But everything else was positive. Now we have x plus 6 times x minus 6. So we have a positive 6 and a negative 6. I'll put this back here so that it's easier to write. Maybe I'll use this one. X plus 6 times x minus 6. Good. First, outside, inside, last. The first is x times x. Outside, x times negative 6, which is a negative 6x. Inside would be 6 times x, but it's a positive 6. And then 6 times negative 6 for our last. Negative 36. X squared minus 6x plus 6x minus 36. This is interesting. So we have the like terms of minus 6x plus 6x. And they cancel out. Negative 6 plus 6x, 0. 0x is just 0. So it's x squared minus 36. What do you think is going to happen here? So this was x plus 6 times x minus 6. The only difference between these two binomials is the sign. Positive. This one was positive. This one was negative. This one's negative. This one's positive. So what do we think might happen here? What we got was x squared minus 6 squared, right? Because x squared is x squared and 6 squared is 36. So we might imagine that this is going to be a squared minus 9 squared, or a squared minus 81. Let's try. First, outside, inside, last. First is a times a. Outside is a times 9. 9a. These are hard to tell. My a's and my 9s look the same. Great. Inside would be negative 9 times a. And then outside would be 9, or last would be negative 9 times 9, which is a negative 81. So all that becomes a squared plus 9a minus 9a minus 81, which is a squared minus 81. Okay, p plus 4q times p minus 4q. P times p plus, right, we add them all. P times negative 4q. So I said negative 4 times p times q. Plus 4pq. 4 times p times q. I'm just putting it in alphabetical order. You can also call it 4qp, but I'm putting it in alphabetical order. Plus 4 times negative 4q times q. So here was p times p for first. Here is p times negative 4p for outside. Here is 4q times p for inside. And here's 4q times negative 4q for last. P times p is just p squared, negative 4pq, positive 4pq. Positive 4 times negative 4 is minus 16. Q times q is q squared. Now, it looks like we have like terms, just like the 9a and the negative 9a were like terms up here. Negative 4pq and positive 4pq are like terms. Negative 4 and positive 4 just leave us with 0pq, so it would be p squared plus or minus 0pq. It doesn't matter if you add or subtract the negative. Minus 16q squared. 0pq is the same as 0 because there are none of them. So it's p squared minus 16q squared. Looking similar, right? We have a positive and a negative. First, outside, inside, last. 3 more problems. First is x squared times x squared. Outside is x squared times negative 12y. Inside is positive 12y times x squared. Last is 12y times negative 12y. Good. X squared times x squared is x to the power of 2 plus 2, because those bases are the same. When we're multiplying the same base, we add the exponents. X squared times negative 12y is negative 12 x squared y. I'm just putting it in descending order of exponents. That exponent, that variable has an exponent of 2. That variable has an exponent of 1. So the x comes before the y. we're here, we have 12y(x squared), so it's positive 12. Again, x squared goes before y because that's a higher power, higher degree. Good. And then 12 times negative 12 is negative 144. Y times y is y squared. Should have said y 1 plus 1. So all of that becomes x to the power of 2 plus 2 is x to the 4th. Negative 12x squared y minus 12x squared y, positive 12x squared y, minus 144 y squared. Let's look for like terms. X to the 4th, no other x to the 4th. X squared y, x squared y. So these are like terms. A negative and a positive of the same term cancel each other out because they're exact same term, but one's negative and one's positive. So it's x to the 4th minus 144 y squared. All right, these last two examples, those were we're taking it, sorry, we were doing binomial times binomial. Now we are doing a binomial times a trinomial. So it's just a really long one, okay? We're starting with x, okay? X times x squared is that one. X times 4x is that one. And then x times negative 6, don't forget the negative sign, is that one. All right, that's the x. And then let's do the negative 4. Negative 4 times x squared plus negative 4 times 4x. We'll pretend that's one piece of paper. Plus, so that was negative 4 times x squared, negative 4 times 4x, and then negative 4 times negative 6. All right, let's see if we can simplify it. X times x squared is x to the power of 1 plus 2, or x to the 3rd, right? Plus x times 4x is 4x. And there were two powers, right? X times x is going to be x squared. Plus, this is x times negative 6. Negative 6x. Now we're looking at, I just went to one font or one color, so it's hard. Negative 4 times x squared. Negative 4x squared. And then here we have negative 4 times 4x minus 16x plus, and then what's negative 4 times negative 6? Positive 24. 24. Good. Okay, keep simplifying. X to the power of 1 plus 2 is x to the 3rd plus 4x squared, right? 1 plus 1 is 2. Plus negative 6x is minus 6x minus 4x squared minus 16x plus 24. Good. All right, let's put these in descending order of powers so that we can combine like terms, okay? So we have x to the 3rd plus 4x squared minus 4x squared. Good? I cross them out so I don't get too confused because it's getting very busy. Now, so that was my third degree. Here's my second degree. Where would my first degree be? Negative 6x minus 16x. And then my constant is just 24. Can I combine any of these like terms? It looks like these two are like terms. And it looks like these two are like terms. Okay. So that will be x to the third. We're going to add 4x squared minus 4x squared. It's going to disappear because those are 4x squared and 4x squared, but one's positive and one's negative. So 4 minus 4 is 0x squared, so they just cancel. Negative 6x minus 16x is just negative 6 minus 16. You're combining them, you get 22, but they were both negative. So it's negative 22x plus 24. So here we have x squared and 4 minus 4 is 0. 0x squared is just 0. All right, guys, last one. Our last one. Should I go down? This way is kind of easier, right? So first we're going to do 7x times x squared. And then we're going to do 7x times negative 5x. And then I'm going to do 7x times 1. Then I'm going to move on to the 3. And I'm going to do 3 times x squared. 3 times negative 5x. And 3 times 1. 1, 2, 3, 4, 5, 6. There were 6 pairs to multiply, right? Okay, let's see what happens. 7 times x squared, or 7x times x squared, excuse me, is going to be 7x to the third, right? Because that's x1 times x to the power of 1 times x to the power of 2 is x to the power of 3. 7x times negative 5x, 7 times negative 5 is a negative 35, and then x times x is x squared. 7x times 1 is a nice one, it's just 7x. 3x times x squared is also nice, it's just 3x squared. 3 times negative 5x, 3 and negative 5 is just negative 15, and then there's just one variable, and then the last one, there's no variable. 3 times 1 is just 3. So let's take those numbers. A little bit easier when you go straight down, I think. 7x to the third, and we're going to add them all, okay? Plus negative 35x squared. You can also just put minus 35x squared. Plus 7x. Plus 3x squared. Oh my gosh, minus 15x. Plus 3. All right, that was looking silly, so I fixed it. Instead of plus negative 35x squared that I messed up, I just put minus 35x squared. Let's put them in order. Remember, this is a degree 3, that's a degree 2, that's a degree 1, that's a degree 2, that's a degree 1, that's a degree 0. If you put them in descending order of degree, oftentimes it puts them in orders to group them, but sometimes it doesn't. So 7x cubed minus 35x squared, where's the other second degree, plus 3x squared. Now we're done with the 2's, we'll go to the first degrees, plus 7x minus 15x, and then the 0 degree is the 3. Now, how can we combine these like terms? Are there any like terms? 7x to the third. There's no other x to the thirds. Negative 35x squared plus 3x squared, you can combine those. And then plus 7x minus 15x, you can combine those. And what we get is 7x cubed, negative 35 plus 3. You're subtracting 35 minus 3 is 32. but the 35 is a negative, so the 32 is also going to be a negative because that's bigger than the positive 3. And then 7x minus 15. 15 minus 7 is 8. So it's minus 8x plus 3. All right, guys, that is the end of multiplying polynomials. Yeah, email me if you have any questions, and have a wonderful day.